Here you can see that first three numbers are non-zero digits. Like this, any number from 1 to 9 except 0, those numbers, they are significant. Here I am removing the rightmost number as a 7. We know that 7 is more than 5. If it is more than 5, this preceding number should be increased by 1. So we can round off to 1.33. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last session, we were discussing about the unit called Some Basic Concepts of Chemistry. Under that, we have studied about the scientific notation. Can you recall it? What is the scientific notation? It's very simple. In a scientific notation, any number can be written in the form of n into 10 power of n, where capital N, which is nothing but a quotient, whereas the small n is nothing but a exponent. And other, we also do the sum of the mathematical operation by using scientific notation, right? So we have done the addition, subtraction, multiplication, and also with the division by using scientific notation. And also I have given few tips while doing this mathematical operation. Only thing is you have to know that whether the exponents are same or not. If the exponents are same, you can do the addition and subtraction. When the exponents are different, we have to make the exponents same or with the exponents same while doing the addition and subtraction. But in the division and also in the multiplication, we have to be very careful, because in the multiplication we are just adding the exponent, whereas in division, we are just subtracting the exponent. But in the multiplication we are just adding. So that also few tips that I have given in my last session to make you to understand about the scientific notation. Today, let us move on to the next topic. So, we are going to discuss with the precision and also with the accuracy, and also we are going to discuss with the new term known as scientific figures. So, we are going to discuss with the significant figures, okay? And also, we are going to discuss with the rules for the significant figures and the mathematical operation and the rounding of numbers and the dimensional analysis. Let's see what is the precision and accuracy in the chemistry. We all know that we used to do the experiment in the laboratory, right? While doing or while performing the mathematical operations after your experiment, you have to report the results by using the two important terms. The first one is precision and second one is the accuracy. These are the two important terms that we use to express our results after getting the results from the experiment. Then what is the precision now? So precision, it is nothing but a set of closed value obtained from the identical measurement. So it is nothing but a closeness of the set of value obtained from the identical measurement. Suppose I am doing a titration. So how many times I have to do? At least 2 times, 3 times or 4 times. After doing the 4th trial, I'll just compare those values. If the values are closer to each other, then we say it is a precise one. Okay. So then we say it is a precise one only when the values are very closer to each other. For example, if I get a 10.1 in my first trial and 9.9 and 9.8, like that, if I got no, these are the values, they are very closer to each other, then we say it is a precise value. And another terminology will be there, that is known as accuracy. Accuracy the differences between the mean value and with the true value. It is nothing but the average of the mean value with the true value. How to find out that? So, imagine you are doing an experiment where the true value for the result is 2.0. Okay, the results of the true value is 2.0. Suppose if you do that same experiment by taking two trial, then you will report the value as 1.9 and 2.0. Then we will take out these two trial and we will add and we will divide with the 2 and we will get the average of 1.9. Okay, the differences between these, that's the mean value with the true value, then it is said to be accurate value. If the value which is obtained by the average of those two trial, if it is same as that of the true value, then we say the result is accurate. This is how the scientists, after doing a many experiment, they started using this two different terminology. First one is a precision and second one is a accuracy. So, precision is nothing but a set of closed value obtained from the identical measurement. If the values are closer to each other, then we say it is a precise value or precise one. Then we say, when we talk about the accuracy, the accuracy means the differences between the mean value or with the true value. How to find out that? Taking out the results like 1 trial, 2 or 3 trial, take the average of that, compare that average value with the true value. If the mean value which is similar to that of the true value, then we say it is a result is accurate. So, this can also be illustrated with this example. Here, I have taken out the example of the 3 different students. They have did the same titration and they have got the different result. For this titration, I have taken out the true value as 2.0. Okay, let's see how to say that results in terms of precision and also with the accuracy. The student here, he did the titration and he did a 2 trial and he got 1.95 and 1.93. If you see these results, you can clearly see that these values are closer to each other. Hence, your result is precise. Okay. Coming into the accuracy, if you have taken out the average of these two by adding those trials and dividing with the 2, you will get 1.940. So, if you see this value, whether it is same as that of the true value? No, it is not same because the true value is 2 whereas our average value is 1.940. It is far away from the true value. Hence, the result is not accurate. Understood? This is how we can express the results by using the precision and also with the accuracy. So remember, precision is a set of closed value obtained from the identical measurement, whereas the accuracy, which is obtained by the differences between the mean value with the true value. The second student, he also performed the same experiment and he got the 2 trial. In the 2 trial, he reported the result as 1.94 and 2.20. Whether the results are very closer to each other? No. Then we say it is a not precise. Coming into the average one, 1.995, which is far away from the 2.0. Then we say it is a neither precise or not accurate. Neither precise or not accurate. Coming into the student C, he did the same experiment and he reported the results with the 2 trial. The first one trial says that it is a 2.01 and second one is 1.99. If you see these results, the results values are almost closer to each other. Hence, we say it is a precise one. Okay. And you can see that the average of these 2 trial, it is 2 only, which is same as that of our true value. so that the students see the result is more precise as well as accurate. More precise as well as with the accurate. This is how, by looking at the trials and also with the true value along with the average value, we can express the results in terms of precision and also with the accuracy. Hope you all understood with this two terminology which is used by the scientists as well as in our labs. Now we'll move on to the next topic, that is significant figures. What is the significant figures is? Usually, significant figures are known as digits. They are nothing but digits. So, these are known with certainty. These are known with certainty. Which means to say that, suppose imagine you are doing a titration. Okay? After doing the first trial, you will get the value of 2.3. Okay? You will get the endpoint at 2.3. So, from this result, how to find out the significant figures? Already we come to know that significant figures are the digits which are known with certainty. Which means to say that after getting this result, we can see that true is the actual value, but 3 is a fraction which comes after the decimal, which are known with uncertainty. Which means to say that they are nothing but a something error which is caused in your experiment, right? While doing the chemical experiment, so many errors will come. So we know that this is the correct one, but after this, decimal is there and so many fractions will be there. That shows that the significant figures that help us to find out this uncertainty or the errors which is found in our experiment. If any experiment, if you do, if any uncertainty which is found, then we can easily identify it by using the significant figures. Okay, that is why I have made the definition that significant figures are the meaningful digits which are known with certainty. Okay, or else you can define it as it is a meaningful digits that helps to identify the uncertainty in the measurement. What is that uncertainty? These are known as errors. These are known as errors. They are also known as uncertainty in the chemistry. Here I have given the example of the result which shows that it is 11.3 ml. Here 11 is the correct value but 3 is uncertain, right? The 3 is uncertain. So that was usually identified by using this scientific figures. Okay? 11 is certain and 3 is uncertain. That is identified by using scientific figures. Understood? By using the scientific figures, we can easily identify the uncertainty or the errors. For the examination point of view, it is very important. Especially for the 1 mark and also while splitting the 2 mark as well as in the 5 marks, they are going to ask to find out the scientific figures. Okay? So, they will give some of the digits just to find out the scientific figures. Now, let's see how to find out it. Okay? So, if you wanted to find out this significant figures which is present in the numbers, we have to follow the certain rules. So, which are all the rules? The first rule says that all non-zero digits are significant. All non-zero digits are significant. Non-zero digits means from 1 to 9. Okay, from 1 to 9, which are the numbers are there, then they are known as significant figures. They are significant. Okay, for example, if you take 292, so how many significant figures are there here? Count 1, 2, 3. So the significant figures is 3. Okay, all non-zero digits from 1 to 9. So don't consider 0 for this. From 1 to 9, if you consider, if you made any numbers or if you write any digits, that will comes under the significant figures, and you can easily identify the significant figures from that digit. Another example I can give you is 4, 5, 6 or 7. How many significant figures are there now? There are 4 significant figures are there in the above example. So that is the first rule. The second rule says that 0 preceding to the first non-zero digits are not significant. The 0 between two non-zero digits are not significant, which means to say that suppose you have 208, okay? Between these two non-zero digits, there is a 0, right? Between the two non-zero digits, there is a 0. In such cases, we should not consider those value because it is a not significant. Those values are, it should not be considered because it's not so significant. Understood? So 0 preceding to the first non-zero digits are not significant. Sorry, don't take this. So this is all about the significant figures. Now let's see which all the rules will be there to find out the significant figures in the number. Let's discuss. The first rule says that all non-zero digits are significant. All non-zero digits are significant. So if you consider the numbers from 1 to 9, if you write any numbers, that are significant. Example, 7 to 9. How many significants are there in above example? There are only 3. Okay? 1, 4, 2, 3. How many significant figures are there here? 4. Like this, any number from 1 to 9 except 0, those numbers, they are significant. So, all non-zero digits are significant. The second rule says that 0 preceding to the first non-zero digits they are not significant. So, which means to say that 0, 0, 0, 2, 3. 0 preceding to the non-zero digits. So here you can see that so many zeros will be there just before the non-zero digits. In such cases, we should neglect this 0 which comes before the non-zero digits, and then we have to take out only with this non-zero digits. Okay. So here the significant figures is 2. Okay. Just we are counting the number of significant figures which is present in the second case. Remember, the second rule says that 0 before the non-zero digits. So instead of this, you can use before also. Preceding means before. Okay. 0 before the non-zero digits are not significant, which means to say that we should not consider those zeros. We have to neglect it. Regarding the non-zero digits, whatever the digits are there, we have to consider and we have to report that how many digits scientific figures are there in that particular number. Understood? And the third rule says that zeros between two non-zero digits are significant. Zeros between two non-zero digits are significant. For example, if you take 208, okay, 208. Here, the 2 and 8 are the non-zero digits. Between these non-zero digits, there is a 0. So, if zeros are present between the non-zero digits, then it is a significant figures because they are significant. So, if you count here, there are 3 significant figures are there because it is present in between the two non-zero digits. Okay. Another example is 20009. How many significant figures are there now? You can count 1, 2, 3, 4, 5. 5 significant figures are there. This is how each rule will tell us to identify the significant figures in the different cases. Okay. The last one rule says that 0 after the non-zero digits are significant if decimal point is there. So 0 after the non-zero digits. For example, if I take 500. So if the 0 present just after this non-zero digits are significant only when the decimal point is there. Only when the decimal point is there. They are said to be significant figures. How many significant figures are there? 1, 2, 3 and 4. If there is no decimal point, then if I write 500 as such or 5000 as such, is there we consider the number of significant figures here? No. Here the significant figures which cannot be counted. So these are the 4 important rules which is given by the scientific community just to identify the scientific figures. Just to identify the scientific figures, and it's very simple to identify the scientific figures. The first rule says that all non-zero digits are significant. Except 0, all digits are significant. Okay. Second rule says that if zeros are present before the non-zero digits are not significant. So, we have to neglect the zeros which is present before the non-zero digits. Only the non-zero digits are considered and we have to report it as a number of significant figures. Coming into the rule 3. The rule 3 says that the 0, if it is present between 2 non-zero digits are significant. If it is present in between 2 non-zero digits, then the results will be significant. Okay. So, we have to report it. The fourth one says that the 0 comes after the non-zero digits. Only when the decimal point is there, we have to consider. If there is no decimal point, then we have to neglect it, which is because it is not a significant figures. Okay. These are the rules. You have to keep it in your mind before identifying the significant figure. Okay. Here, I have listed out the few examples of the significant figure and you have to identify by applying the rules. So, as we all know that here 0.0025. Here you can see that rule 2 will be applied. So, rule 2 says that if the zeros are present before the non-zero digits, then we have to neglect the 0, only the non-zero digits are considered. So, here the significant figures is 2 because only 2 digits are there. Okay. 2 only non-zero digits are there. Coming into here, the second example 208. So, the rule 3 will be applied. Rule 3 what says that if the zeros are present between the 2 non-zero digits, it will be considered. So, here how many significant figures are there? 3. Understood? The same rule will be followed here. Rule number 3. So, here 1, 2, 3 and 4. 4 significant figures are there. Coming to the next one, here you can see that rule number 4 will be applied. Here you can see that first 3 numbers are non-zero digits. After this, there is a large zeros will be there. That is 3 zeros will be there. So, we come to know that we can identify this significant figures only when the decimal point is there. If there is no decimal point, in such cases, we have to neglect this 0. Only we have to consider the non-zero digits. So, here only 3 significant figures will be there. Coming into this one, here again rule 4 will be applied. So, that here decimal point is there. So, here there are 4 significant figures will be there. Coming into this, here also same thing will be applied. And for this, 1, 2, 3, 4 and 5. So, 5 significant figures will be there. This is how in your examination by giving this numerical, they are asking you to find about the scientific figures. And it's very simple. Keep the rules, how we apply and then identify the significant figures which is present in the digits. Okay. Then we'll move on to the addition and subtraction by using scientific figures. So in scientific figures, how do we do the addition and subtraction? Let's see. In addition and subtraction of a number having the different precision final values, it should be reported to the same number of decimal places as in term having the least number of decimal places. So, while reporting the results of addition and subtraction in case of scientific figures, we have to make sure that whether the least number will having how many decimal places. So, here you can see that here I have taken the example of 3.52, 2.3 and 6.24. So here there is only 3 significant figures are there, right? 3.52. So after decimal there are only 2 uncertainty will be there. That is the error. So here also, here there is a 1 uncertainty, here there is a 2 uncertainty. After adding those values, we have to report the results as the least number which consists of the decimal places. Here the least number is 2.3 and it having only 1 decimal places. So we have to report the result as 12.0, not as 12.06. Okay, this is how while doing the addition as well as with the subtraction, we have to report the results in the least number with the decimal places. Let's see in the subtraction. In subtraction, same thing will be follow. Here the least number is 12.11, right? So after subtraction, we have to report the result to the least number with the decimal places. The least number is 12.11 with the decimal places only 2. So we have to report the result to 11.36. Don't write the full example. Don't write the full digits, just you have to make sure that whether the least number having how many decimal places. Okay. Next, we'll see how do we do the multiplication as well as with the division. Especially in the multiplication and the division, the final result should be reported up to the same number of the significant figure as they are present in the least precise one. So while doing the multiplication, we have to see that how many significant figures are there. The least numbers or the least significant figures, if it is present, we have to report it as that of the least decimal places. Okay, here the number will be having 3 significant figures and here there are 4 significant figures will be there. But while reporting the result, we have to report it up to 0.024 because it has only 3 significant figure, so that the least number has 3 significant figures, so that result should be reported to 3 significant figures. Coming into the division also. In the division, same thing. You have to divide the values, and while reporting, we have to see that the least one which having how many significant figures. Here 7 and 6 are the 2 significant figures, but here 2 to 1 are the 4 significant figures. So that final result should be 1.12. So be careful while reporting the results. We have to know that how we are going to report the results with the significant least number with the decimal point as well as with the least number with the significant figures. Okay, it's so simple. You can keep it in your mind. Next, we'll move on to the rounding of the numbers. Next, we'll move on to the rounding of this number. So, already we come to know that significant figures are nothing but meaningful digits which are known with uncertainty, right? So, the lot of errors will come when you do the experiment. So, after getting these results, how to round off into the numbers, let us discuss. And for this also, we have only 3 rules while round offing the numbers. So, the first rule says that if the rightmost digit is removed is more than 5. If the rightmost digits are removed, if it is more than 5, then preceding number should be increased by 1. preceding number should be increased by 1. Example, 1.327. Here, I am removing the rightmost number as a 7. We know that 7 is more than 5. If it is more than 5, this preceding number should be increased by 1. So, we can round off to 1.33. How it become 1.33? Because we are removing the last number. If the last number is more than 5, then the next number should be increased by 1. So, it should be round off to 1.33. Coming into the rule 2. Rule 2 says that if the rightmost digits are removed, if it is lesser than 5, then the preceding number will not get changed. If you remove the last number, if it is lesser than 5, okay, then preceding number will not get changed. It should not be get increased by 1. It should be keep it as such. Okay. So, it becomes 4.32 only. If you remove also, we should not increase any one number or we should not do any subtraction also. We have to keep the result as such because according to the rule. The third rule says that if rightmost digits are removed is 5, then preceding number is not changed if it is an even number. But it is increased by 1 if it is an odd number. So imagine you are taking this number 6.25. You are removing the last number as a 5. Okay. So if you remove the last number, the next number is 2. That is an even number. That is 2, 4, 6, 8, 10 other even numbers, right? So if the even numbers are there, then it should not be increased by 1. We have to report the result as such. Suppose, if you are removing the last digits as 5, next number if it is as odd number, then it should be increased by 1. It should be increased by 1. This is how when we are doing the chemical experiment, we have to round off the number by applying this 3 rule. Okay, the last rule is very simple. If you are removing the last number as a 5, if the next number is even number, it should not be changed anything. We have to report the result as such. If the next number is odd number, then we have to increase by 1. So these 3 rules, which are the basis for you to understand the chemistry while doing the mathematical operation, especially by rounding off the numbers. Coming into the last one, that is dimensional analysis. What is this dimensional analysis? Already we have come across with the significant figures, precision, accuracy, then rounding off method. What is this? This is another type of method where we are converting the one unit into another unit. When we are doing the mathematical operation, especially with the calculation, sometime you would have observed that we are converting one unit into another unit. So, this is known as dimensional analysis. While calculating, then we need to convert the one unit into another unit, and the method will be used for this is known as dimensional analysis or factor label method or the unit factor method. Factor label method or unit factor method or dimensional analysis where we are converting the one unit into another unit. Example, you can see that from the inches to the centimeter, we can convert it. From a centimeter to the inches, we can convert it. And from the grams to the kilogram and from the kilograms to the gram. This is how from one unit to another unit also, we can convert it in a chemistry by using dimensional analysis. Okay. Let's solve this problem. How do we convert from one unit into another unit by using the dimensional analysis? Here you can see that a numerical says that a piece of metal with the 3 inches, what is its length in centimeter? So they have given a piece of metal with the 3 inch. Okay, we have to find out the length in centimeter. So we have to convert the one unit into another unit by using the dimensional analysis. Okay, how to convert it? We all know that 1 inches, which is equal to 2.54 centimeter. 1 inches, which is equal to 2.54 centimeter. So by writing this equivalence, we can write this above equation as 1 which is equal to 1 inches divided by 2.5 centimeter. After writing this relationship, we can write 1 which is equal to 1 inches divided by 2.5 centimeter. 2.54 centimeter. Okay. Or we can write 1 which is equal to 2.54 centimeter divided by 1 inches. 1 inches. So there is a two possibility to write this. 1 which is equal to 1 inches divided by 2.54 centimeter, or 1 which is equal to 2.54 centimeter divided by 1 inches. So this is known as unit factor. Unit factor, where we are converting the one unit into another unit. Okay. After getting this unit factor, okay, we have to see the form. We have to see the numerical. What I have given to find out the 3 inches. Okay, the metal which is having 3 inches, we have to report the result in the length in the centimeter form. Right. So that I can write 3 inches, which is equal to 2.54 centimeter divided by 1 inches. Divided by 1 inches. 1 inches. So here the inches and inches will get cancelled, and if you multiply 3 with the 2.54 centimeter divided by 1, you will get 7.62 centimeter or 7.64 centimeter approximately. I have written here. So 7.62 centimeter is the results of obtaining the or measuring the 3 inches of a metal. This is how, if they have given from the one unit, you can convert it into another unit. So the simple example I have shown here how to find it out. Okay. So here the inches will be get cancelled. So the remaining things will be get multiplied and divided. You will get the answer. Okay. This is how the dimensional analysis is so important for the chemist to convert from one unit into another unit. So from this session, we have learnt a lot about the scientific figures, about the precision, and to say the results especially, okay, we use the two terminology, that is a precision and accuracy, and also to express the results in terms of scientific figures also we have learned the rule. After obtaining the scientific figures, we have learned that how to round off the values to the nearest one, right? And also we have come to know that how to convert from one unit into another unit. I hope you all enjoyed with this session. In the next session, we are going to discuss with the law of chemical combinations. Okay. So by this, I like to say that what we have discussed today, please try to note down in your notebook and try to practice it. And in your NCERT textbook, you have many problems regarding to the dimensional analysis, and you can work out with that. And also, if you see the model question paper, you can see that scientific figures, they have given the questions. So if you see that question, and please try to answer for those questions. If you don't understand, you can watch this video and you will come to know that. Till that, take care. Thank you. We'll meet you in the next session. Thank you.